humidity, airflow, and air filtration. The mechanical intervention to condition the air to a preferred temperature and relative humidity is known as HVAC. Human comfort. Condition at which most people are likely to feel comfortable most of the time, also called as thermal comfort. The temperatures in summer 78°F, winter 68°F, relative humidity 30 to 60%. By using HVAC system, temperatures can be raised or lowered. Humidity can be raised or lowered. Maintain proper filtration of air. Proper air movement. Outside air can be added or removed. To hold the air contamination within the acceptable limits. Applications of HVAC system. Residential, commercial, industrial, educational, pharmaceutical, hospitals, malls, offices, and many more. Heat transfer. Heat flows due to hot body to cold body. The heat transfer is also classified as conduction, convection, and radiation. Conduction is a transfer of heat through solid matters. Convection is a transfer of heat through liquid molecules. Radiation is a transfer of heat through gas or air. Degree temperature can be measured in degree centigrade and also in degree Fahrenheit. Heat transfer. How does a heat transfer? Through exterior walls, solar glass, infiltration, roof, floor, partition walls, people, lights, equipment, etc. Factors affecting human comfort. Dry bulb, humidity, air movement, fresh air, clean air, noise levels. Adequate lighting. Major components of air conditioning. Compressor. This component is the heart of the system. Pump refrigerant and oil through system. Separates high pressure side from the system of low pressure side. If it fails, no cooling takes place. Condenser. Condenser coil is what gets rid of the heat in the system. Can be water cooled, located inside, cooled with cooling tower, or air cooled, located in outside open to atmosphere type. Traps dirt and requires preventive maintenance and cleaning. Evaporator. Provides cool air to the space. Located after the system in air filters. Remove moisture from air. Traps inside dust in filters, so requires preventive maintenance also. Evaporator fan. Located behind or in front of the evaporator coil. Draw ambient and mix air across the evaporator coil. Thermal expansion valve. Located at the evaporator coil. Provides the correct amount of refrigerant to the evaporator coil for proper cooling. Separates the high pressure side of the system from the low pressure side of the system. Failure could cause compressor failure and loss of cooling capacity. Refrigeration cycle. The basic refrigeration cycle consists of four major important components: compressor, condenser coil, expansion valve, and evaporator coil. The right hand side is the high pressure side of a refrigeration cycle, and the left hand side is the low pressure side of the refrigeration cycle. As you can see, the hot air, when compressed, passes through the condenser coil. This is the high pressure gas, where after the heat rejection from the condenser through air or through water, depending on the system, the hot liquid is passed through the expansion valve. The expansion valve, depending on the requirement, flows the cool liquid out of the expansion valve, and it passes through the evaporator coil and again back to the cooler gas. Cool gas is passed through the compressor. The process of cooling happens at the evaporator coil, which is also known as the cooling coil. Unit of refrigerant. 1 TR is amount of heat to be extracted from the atmosphere for melting 1 metric ton of ice in 24 hours. 1 TR tonnage of refrigerant is also 12,000 BTU per hour, 3,000 kilocalories per hour, 50 kilocalories per minute. System selection. How do we select a system? What are the requirements? What do we need to do for selecting a proper system? Steps for selecting a system. Calculation of cooling load requirement. Selection of techno-economical system. Equipment selection. Designing an air distribution system. Designing water distribution system. Designing refrigerant distribution system. Evaluation of the system to be used. Factors to considering during the cooling load requirement. Building detail layout. Use of the space. Physical dimension of space. Inside room design condition. Filtration level. Ambient condition. Glass area exposed to sun. Occupancy. Lighting load. Equipment load. Fresh air requirement. Infiltration of outside air. Factors affecting system selection. Budget of the client. Need and requirement of the client. Use of the space. Outside condition. Floor layout. Location and dimension of beam and column. Power availability. Space availability. And many more. There are different factors which needs to be considered while selecting a proper system. These are the basic factors, and it can be many more to the system. Psychometric chart. Psychometric chart is the important process to identify air properties. What is psychometric chart? A psychometric chart is a graphical representation of the process of air. Psychometric process include physical and thermodynamic properties of air. Provides a graphical representation of air and its properties. Knowing any two conditions of air flow allows the other condition of the air to be found. Properties of air. Dry bulb, wet bulb, humidity, dew point, moisture content, heating, cooling. Types of air conditioning system. The basic types of air conditioning system is DX, direct expansion. A direct expansion air conditioning system used a refrigerant vapor expansion compression cycle directly cooled by supply air to an occupied zone. DX system, both package and split, directly cools the air supplied to the building because the evaporator is the direct contact with the supply air. A typical example of a direct expansion system where you can see the compressor, condenser, expansion valve and the fan, which is known as the blower, is in a closed circuit where the refrigerant itself is the source of cooling. This is a typical example of a direct expansion system. Chill water system. Chill water air conditioning systems are commonly used in the application that need large cooling capacities such as hypermarket, industries, process, and commercial air conditioning at offices and factories. This system makes use of water as its secondary refrigerant. Chiller is used to remove the heat from the water, which is then circulated through other components to absorb heat from the space. Where a chilled water system is a combination of DX and chill water, where the refrigerant acts as a primary system and the chill water acts as a secondary system. A typical example of a chill water system where you can see the cooling tower, chiller, fan coil air handling unit and fan coil unit. In the chiller, the refrigerant acts as its primary system, and whereas the water which is flowing through the evaporator of the chiller and to the AHUs and the fan coil unit act as a secondary system where water is supplied. Major types of air conditioning system: window AC, split AC, cassette AC, package AC, AHU air handling unit, which can be DX or either chill water system. Thank you very much.